Hello everyone. So today we're going to think back to the border problem that we did a few weeks ago where I showed you that big square. There's like a 10 by 10 square and you had to figure out how many tiles were in the border without actually counting it. And so you came up with all kinds of different methods of doing that. And then you tried it with this 6 by 6. We talked about how that would look with the 6 by 6, and then finally an n by n. So you can see here in this column, this was our n by n column. And we talked about how these really are just different ways of expressing the same thing. We know that the number of squares in the border was the same no matter how you counted them, but they can be expressed differently. And so today we're just going to look at two of the representations that you came up with. So there was this one, the n minus 1 times 4. So that's where you were taking, like if you remember, you have the border like this and the squares inside. So this is where you were counting that you kind of took one off of each, so that if it was like the 10 by 10, you'd have 9, 9, 9, 9, and you're timesing that by 4 to get the total number. So for an n-sided one, if it was n by n, you'd be taking 1 off and then multiplying by 4. And then another representation that you came up with was that we take the number of tiles on each side, subtract by 2, kind of to make up for that double counting, because all of these corners belong to two different sides. So we're going to take off 2 from this side, and this side, and this side, if that was a 10 by 10. But then we have to add them back on. So we have to add them back on here. So we multiplied it by 4, and then we added the 4 corners back on. So that was two ways that you had to look at it. And so today we're going to look at how we simplify this to 4n minus 4. So the first thing to note is that this one here, the n minus 1 times 4, that is equivalent to writing it like this with 4 times n minus 1, because it doesn't matter what way we write multiplication. And so then something to think about is that we are taking this n minus 1 and we're basically making 4 copies of it. That's what it's saying. So if you like to use algebra tiles, you might think of this as like, this is your n and this is your minus 1. So n and minus 1, and you might use opposite colors. I think about red being hot, so positive, and blue being cold, so negative, but it doesn't really matter what colors you're using here. But I have to make 4 copies of that. So here's my 4 copies of this n minus 1 right here. Bring one over to the other side. So 4 copies of that. So what do I have left here? Well, I have 4 n's now, 1, 2, 3, 4. So 4 n's, and I have also minus 4, 1, 2, 3, 4. So that's another way of writing that. And if you don't want to use algebra tiles all the time, what you might want to think about is that we're really multiplying the 4 times n, which is 4n, and then the 4 times negative 1, which is negative 4. So we call this the distributive property, this idea. If you want kind of the general form, the idea is that if you have anything multiplied, so something outside the brackets being multiplied with multiple things inside the brackets, each of this A gets distributed to each of the things inside the bracket. So this is equivalent to A times B plus A times C, which is what we just saw. So let's look at that other representation. So here, if we deal with this first part, this is saying we have 4 copies of n minus 2. So let's look at that again. So here's n, here's minus 2, and I have 4 copies of that. So here's another n minus 2, and another n minus 2, and another n minus 2. So we can see that now I have 4 n's, n. So 4n, and 2, 4, 6, 8 minus 8, which is what we would expect. If we use that distributive property that I just showed you, 4 times n is 4n, and 4 times negative 2 is minus 8. And then I still have this plus 4 here that we have to consider. But there we can just combine the like terms. So negative 8 plus 4 is negative 4. And so I have 4n minus 4. So we've seen here now that both of these do end up being 4n minus 4. And so that's why, even though they're represented different ways of thinking, it's still represented the number in the border. Okay, so let's do some examples of this distributive property thing. So here we're going to expand and simplify. So what that means, expand, it just means you're getting rid of the brackets because you're multiplying in, so you want to get rid of the brackets. So for this one, just like we just saw, we can multiply. What it means is 2 copies of x plus 5. So you could think of it that way and kind of think of the algebra tile way, or we can multiply 2 times x, which is 2x, and then 2 times 5, which is 10. And that's all there is to it. And we know if you had x plus 5 and then another x plus 5, you'd have 2x plus 10. This is kind of interesting because we have just a negative in front. So when you just have a negative like that, you could consider this like an invisible 1 if you want, where we're multiplying in a negative 1 times each of these. So negative 1 times 3x, that's negative 3x. And negative 1 times 1, sorry, is minus 1. Another way of thinking of it, when you have like a negative before the bracket, is that you end up adding the opposite. So it turns everything inside here into the opposite sign, which we saw, negative 3x and then minus 1. Okay, let's try another one. So here we're seeing lots of brackets, but no need to get overwhelmed. We're just going to do it in pieces. So this first part here, we'll just do the distributive property. So this 2 only applies to the things in the brackets immediately beside it. This part here is a separate part we don't have to worry about. So that we have first 2 times 3y, which is 6y, and then 2 times negative 1, which is minus 2. And then we can do the second part, which again we're multiplying here, 3 times y, which is 3y, and then 3 times 4, which is 12. So the only extra step we have here, because there's some like terms that need to be combined, we need to do that. So we have a 6y and a 3y that should be combined. That gives us 9y, and then there's a negative 2 and a plus 12. Negative 2 plus 12 is plus 10. Okay, I'm going to add one more example here, even though I don't have it kind of typed out, but I think you should see it. If I gave you something like this, and I would recommend that you actually pause the video and try this on your own first, because you have all the tools to do it. So if you're doing this, you're going to, just like the other questions that we have been doing, you're going to kind of split it into 2 parts. So here's the first part, and then here's the second part. So for this here, I'm going to distribute it in negative 3 times 4x is negative 12x, and then negative 3 times 5y is negative 15y. I'm just going to do the other part in another color just to keep it clear. So now I'm going to do this part here. So again, remember this negative here. It's like a negative 1, invisible negative 1, or it makes everything inside the brackets become the opposite. So negative 1 times x is minus x, and then negative 1 times 3y is negative 3y. Okay, so just something to be careful of there. And so then we can continue to solve this. We have some like terms. So negative 12x minus x is negative 13x, and negative 15y minus 3y is negative 18y. And just recall from when we were talking about like terms that you can only combine things that are the same. So like this might be, the statement here is kind of like saying, this doesn't make sense, but I have negative 12 apples minus 15 oranges minus 1 apple minus 3 oranges. So you're not going to combine them all together because they're separate things. But you can combine all the apples together to give negative 13 apples, and you can combine all the oranges together to give negative 18 oranges. Okay, so it's time for you to practice now, and this is something that just, it's like a skill that gets better with practice. So make sure you put the time and effort into practicing.